All right, today we're going to take a look at 7-8 using exponential and logarithmic functions. So we're going to look at some real world application that you might see these in. So one of the things you're most likely to see exponential and logarithmic equations are looking at growth and decay functions. These are very similar, and we're using base E here. That they're actually very similar. The only difference with the growth and decay is that your rate's either positive or negative for when you're doing growth or decay. Other than that, the equations are exactly the same. A is your initial value. E is a number like pi. It has its own number. We just use E. K is the rate, and as a decimal specifically. And T is generally time in years unless they tell you otherwise. So if we're looking at the half-life of sodium 2020 is 2.6, meaning that it takes 2.6 years for half of it to disappear. We can find the value of K in the equation of first decay. So since we know the initial, we don't really know the initial amount, we're just gonna say A. And we know that what's left over is half of A. We can go ahead and do 0.5 A equals A. But when you divide each side by A, you get 0.5. So usually what I would do here is actually just start off exactly with what they have written here. And so what we're going to do next is rewrite it in logarithmic form, which gets us take the natural log, or you can take natural log of both sides. But I would just go rewrite it in natural log form to get natural log of 0.5 equals negative 2.6K. And we're going to divide by negative 2.6. And then using a calculator that we get K is 0.2666. So you could use that to find out how much of sodium 22 is left after so many years. So go ahead and try this problem here. All right, so what you should get checking your work is you should get C, 0.8666. All right, our next example is a geologist examining a meteorite estimates that it contains only about 10% as much sodium-22 as it would have contained when it reached the surface of the Earth. How long ago did the meteorite reach the surface of the Earth? So we're going to use our formula. This time we don't know T, but we do know A, as again, it's going to be 1. So we know we have 0.1 left. So 0.1 equals E to the negative 0.2666 T. So we're going to head and rewrite this in natural log form. And get natural log of 0.1 is equal to negative 0.2666 T. So we're going to divide. And then we're going to head and using the calculator, we get 8.64. So about 8.6 years ago. Doesn't seem that long. So you can, of course, you can plug in 1 and see what you get once you use 8.6, and you get about 10%. All right, go ahead and try this problem. Pause the video to give yourself a chance. You should get D about 18.58 hours later. We also use these for population calculations. So in 2007, the population of China was 1.32 billion. In 2000, it was 1.26 billion. Determine the value of K for China's relative rate of growth. So we're going to use the growth formula. And we get 1.32 equals 1.26 e to the K7. And we do get 7 because 2007 minus 2000 is 7, so 7 years. We're going to divide each side by 1.6. We're then going to take natural log of both sides. We are then going to divide each side by 7 and then use a calculator to get about 0.0066, which is about a 0.66% growth rate. So we can do the same thing in that we want to know when will it reach 1.5. Now that we know K, we can go ahead and solve for T using the same steps. And then dividing by 0.0066. And it will be about 26.42 years later, which is going to be in 2026, which is something we could actually check pretty soon and see if it did keep that rate. In 2007, again, we're looking at continuous growth. We have China was at 1.32, India was 1.13, and can be modeled by the equation y equals 1.13 e to the 0.015t. So they want to know at what point will India's population suppress China's. Note T represents years after 2007. So this is very important for when you're making those calculations for what we're doing. So we have 1.32, and so they're going to use inequalities here. I'm using the property of inequalities. We're just going to go ahead and solve for this. We're going to use product form. If you're going to use, so they're going to separate. And you can just go ahead and solve, and then you would find that we get about 18.5 years, midway through 2025. All right, go ahead, pause the video, give yourself a chance to try this one. You should get B. Pause the video to give yourself a chance to try it. We should get A, 2009. Pause the video to try it out. You should get D, 2027. I don't believe we're going to do that one. That is the lesson for 7-8, and I will see you next time.